You are viewing locations. இன்னைக்கு அனுப்பிச்சதுல பாருங்க உங்களுக்கு கனெக்டே ஆகல பாரு வாட்ஸ்அப் இதே கனெக்ட் ஆகல பச்சை கலர்ல வந்தாதான் கனெக்ட்
Yeah, good afternoon all. Welcome Dr. Pallav, Dr. Sandeep, and Dipti madam, could you please share your screen for the session chairs, for the introduction of session chairs?
Yes, sir. Yes, sir. 1 minute, sir.
Yeah, Dipti madam, are you there?
Yes, sir. Sir, is the screen visible?
No, madam.
Just a minute, sir. Is the screen visible, sir?
Yeah, yeah.
Yes.
Should I start, sir?
Madam, Manisha ma'am is here. Like just check it once.
Yes, sir. No, not sir. She has not joined. Yes, sir. Manisha Bharti is here. Yes, sir.
Yeah. Good afternoon, madam. Good afternoon, Pallav sir. Good afternoon, Sandeep sir. Thank you for
Good afternoon,
coming.
everyone.
Good afternoon, everyone.
Madam, please proceed. Dipti madam.
Yes, sir. Yes, sir. Yes, sir. A very good morning to all of you. On behalf of Computer Science and Engineering NIT Raipur and 4th International Conference on Machine Intelligence and Signal Processing, I welcome all the respected session chairs and participants. Before we start the session, let me introduce out our esteemed session chairs. Our first session chair is Dr. Manisha Bharti. Dr. Manisha Bharti has completed her BTech.
Madam, your slides are not on full screen. Please make it on full screen.
Okay, sir. Dr. Manisha Bharti has completed her BTech in Electronics and Communication Engineering from Guru Nanak Dev University, Amritsar in 2002. MTech in Electronics and Communication Engineering from Punjab Technical University, Jalandhar in 2007. She received her doctorate in 2017 from IKG Punjab Technical University, Jalandhar, in the field of optical communication and networks. Her area of research include optical communication and networks, analog, digital, and broadband communication circuits, optical signal processing, and VLSI. Dr. Bharti has over 18 years of experience in academics. She worked as assistant professor for 7+ years at Ambedkar Institute of Advanced Communication Technologies and Research, Delhi, under the government of NCT of Delhi, and is currently working as assistant professor and head in Department of ECE at NIT Delhi. At present, she is guiding 3 research scholars for their PhD degree. She has also guided many MTech and BTech students for their projects in different areas. She has published more than 35 research papers in reputed journals, conferences, and proceedings. Our next session chair is Dr. Pallav Bera. Dr. Pallav is a visiting assistant professor at the School of Engineering at Computer Science at University of Evansville in USA. He's also serving as the program director of computer engineering. He received his PhD in electrical engineering from Syracuse University, New York, USA in 2021, and his master's in systems and control from the IIT Roorkee, India in 2014. His research is focused on using statistical analysis and machine learning to secure power systems. And we have Dr. Sandeep Kumar as our next session chair. Dr. Sandeep Kumar received his BTech degree in Electronics and Instrumentation Engineering from the Institute of Engineering and Technology, MJP Rohilkhand University, Bareilly, India in 2006, and his MTech and PhD degree in Electronics and Communication Engineering from the IIT ISM Dhanbad, India in 2008 and 2015 respectively. Currently, he is working as an assistant professor in the Department of Electronics and Communication Engineering, NIT Delhi. He has more than 11 years of teaching and research experience, including more than 1 year in the Department of EIE, NIT Silchar, and more than 4 years in the Department of ECE, NIT Delhi. His research interests include digital signal processing and its application in speech, audio, image, optical, and biosignal processing. He guided 4 PhD scholars, 12 MTech, and more than 25 groups of BTech projects. He has been published more than 50 research articles in reputed international journals and conferences. He is an Indian adapting author for Signals and Systems by Simon Haken and Barry Van Vliet, book published by Wiley. He is an active reviewer of many reputed journals published by IEEE, Elsewhere, Springer, Wiley, etc. He is an active member of IEEE and IEEE Signal Processing Society. Thank you so much, session chairs, for joining the session. May I request all the session chair and participants to switch on their video. In this session, we have 5 papers to be presented. May I request 2 session chairs to start the session. Now I invite our first paper presenter, Mr. Punnus AK, paper ID 61. Titled as A Cross Data Set Approach for Noisy Speech Identification. Over to session chairs.
And who is the first presenter?
Sir, Mr. Punnus AK, paper ID 61.
Is he here?
Not sir. No, sir.
Yes, presenter.
He's not here, sir. He's not present.
Well, you invite the second one. Meanwhile, what you do is you communicate with him first and ask him to join the meeting immediately.
Okay.
And from the list, you invite the second.
Okay, sir. Then I would like to invite Dr. Sangeeta, paper ID 71. Yes, Dr. Sangeeta is here. Titled as audio scene classification based on topic modeling and audio events using LDA and LSA.
share it. One second.
Okay. In meantime, Deepthi, can you ask request for session chairs and participants for a group photo?
Yes, sir.
Yeah, welcome, Dr. Pallav. Dr. Manisha, welcome.
Sorry, sir, I don't have camera.
No issue. If you don't have camera, then no problem. If you don't have any problem in sharing video, then switch on video, then no problem.
No, sir.
If you don't have any problem, yes.
Actually,
Dr.
I
Sandeep,
have,
yeah.
I have,
No
I had,
issue.
I had joined through
Yes.
desktop. That's why.
No issue at all. I'm also facing the same problem 2-3 days before. Okay. Those who can do, please do. And thank you. Yeah.
I would like to request all the presenters to please switch on their video for a group photo.
Done?
Yes, sir.
Okay. Thank you. Now floor is hand over to the session chairs, and you may ask any presenter for the presentation. Thank you, sir. Dr. Pallav, Dr. Manisha, and Dr. Sandeep Kumar. Okay, please.
Ma'am, I'm not able to share the screen, ma'am.
Dipti madam, make him co-host.
Yes, sir. Yes, sir.
Make her co-host. Sorry.
Yes, sir.
Yeah.
Yes, sir. Yes, sir. Yes, sir. I have done it.
And I would also like to request all of you to join the validity session because today is the last day of this conference, and it will be great if you join. Okay. Yeah, your presentation is visible. Please start.
Okay, thank you, sir. So good morning to all. The title is Audio Scene Classification based on Topic Modeling. One second. And audio events using LDA and LSA. So this will be presented by Dr. J. Sangeeta and D. Rekha. So this is what the table of content. It just covers background, literature survey, problem description, methodology, results, and discussion, conclusions, and references. So coming to the background, so audio scene recognition, it's a computational classification problem in the past. So assigning topic to labels to documents that helps for efficient information retrieval. So the way of organizing audio documents with the topic labels helps in sorting, filtering, and efficient searching. It can be used in aquaculture, home automation, biometric identification, telephoning speeches, as well as many applications. So we are just attempted to perform ASR with topic modeling. So that's what the background of the work. So this is what the literature survey. The year 2016, Y. Leng et al. Proposed ASR, which involves identifying the location and surroundings where the audio was recorded similar to visual scene recognition. So in the year 2017, Leng et al. Proposed a semi-supervised algorithm that focuses on the unlabeled samples for STM that was robust to sizes. In the year 2019, Jalodhar H. et al. Proposed every topic is modeled based on the set of probabilities as an infinite combination using LDA. The year 2020, Wang et al. Proposed a robust audio content classification using hybrid-based SMD and entropy-based VAD. So this is what the literature. So coming to the problem definition, so that will be presented by D. Rekha. Proceed.
So good afternoon, everyone. So the problem is topic modeling. In topic modeling, we use it. Topic modeling is a text mining technique. Topic modeling is a text mining technique using semantic structure of the documents, and we group for grouping similar documents. So first we assign topic labels to documents, and then we develop, we use it for an audio document here. So it can be extended to ASR, and we present an analogous counterparts between the text documents and audio documents. Then finally, each frame can correspond to lemmatization results. Okay. Next slide. Then our proposed framework, in a proposed framework, we have the input vocabulary. The input vocabulary initially, we are going to compute the, we are going to give the input vocabulary and the input vocabulary, using the input vocabulary, we compute the documented term co-occurrence matrix, and then we give it to our, we use the LDA or LSA model, and we give it to our classifier. Finally, the classifier classifies the audio document based on a topic. For example, if we give a topic, it will say that whether the audio document belongs to that particular topic. Okay, next slide. Next one. So here the the document to event co-occurrence matrix is calculated for the training set and the test set. That is, the words and documents are taken as input, and we convert it into, we split it into terms and words and terms and documents in the training set. And for the test set also, we take a particular document and words and split it into its corresponding terms and words and terms and documents for efficient handling. Okay, next. So the proposed algorithm, in the proposed algorithm, we use our data set, which we have used on audio acoustic signal processing and the demand data sets. And each and every audio class includes 16 recordings, and each and every audio document is partitioned into 30 milliseconds long frame. For our convenience, we have done it. And there are 39 dimensional MFCC features that are obtained. So we use SVM as a classification algorithm. Okay. Then for evaluating the algorithm, we use the classification. For improving the for calculating the accuracy, we use the following term calculating. That is the number of correctly classified audio documents by the total number of audio documents in the test set into 100 will give you the accuracy. Okay. Then finally, the new ASR algorithm utilizes the document event co-occurrence matrix for topic modeling, which is more efficient as it is using the matrix factorization method. And based on it, we are going to classify our topic. And as a future enhancement, we are also planning to add a neural network model to encompass the topics in the present system. And these are the metrics of our work. We can also add a neural network model. That's it. The references.
Hi. So I have a few questions. Can you hear me? Hello?
Yeah, yes, sir. Yes, sir.
Yes. So why did you choose SVM as the classifier? What was the idea behind that?
So that is the best classifier algorithm.
How did you know that? Like if you don't try different classifiers.
According to the literature.
Okay. So you tried according to the literature, and then you also said that you are going to try artificial neural network, right?
Yes, sir. That is our future enhancement.
So no one has used ANN previously?
No, sir.
Okay. Thank you.
Thank you, sir. Thank you.
Can I ask some questions?
Yes, sir.
So you told about some topic modeling in, I think, first or second slide.
Yes, sir.
What is topic modeling? What
It
you
is,
have?
it is identifying a document based on the topic. That is, similar to identifying a group of documents based on a keyword like that.
Okay, and
Identifying the topics.
identifying the topics.
For example, medical, sports, like that. Sir.
Okay, and what was your input data size which you have taken for the test?
Data size.
Yes.
It is 16 recordings. It is 16 recordings
so
related to 16 channels.
these data sets are freely available, or you have recorded?
Yeah, it is freely available in the net.
Okay, and you have used some data for the training purpose, no?
Yes, sir.
So how much percentage of data you have used for the training purpose?
70%.
70%.
Yes,
And
sir.
what accuracy you got?
95% accuracy I got.
Okay, so have you compared your method with existing one?
Yes, sir, I have compared.
So what was the improvement?
5 to 6%, 5%, sir. Exactly 5%.
5%.
Yes,
Okay.
sir.
So final question: have you calculated the computational complexity your algorithm?
Yes, sir.
Computational complexity. That means how?
Computational complexity.
Yes, or time consumption, like.
No, sir, not at done, sir.
Okay.
We'll make it in the next work, sir.
Okay. Okay. Thank you.
Okay, thanks.
Can I proceed to our next paper presenter?
Shall I leave, sir?
Yeah, I think there are no more questions. So
Okay, okay, sir. Thank you.
thank you.
Okay, now I would like to call our next paper presenter, paper ID 146, Mr. Krishnadev, to present his paper titled as Nepali Voice-Based Gender Classification Using MFCC and MGM.
Good afternoon, ma'am. Good afternoon, all. Ma'am, am I audible?
Yes, go ahead.
I am here to present a paper on the topic Nepali voice-based gender classification using MFCC and GMM. These are the table of, and our voice-based gender recognition is a technique that is utilized to determine the gender category of the speaker by processing voice signal. And it is one of the type of biometrics which is used to detect and authenticate the user based on their speech. Our paper focuses on the implementation of Nepali voice-based gender classification using MFCC and GMM with covariance type tied diagonal. And with the covariance type as tied, we got an accuracy of 93.84, and with the covariance type diagonal, we got the accuracy of 94.16. And our research paper involves a voice classification based on the wave frequency of a voice of different person. This model can automatically identify the gender using the Nepali voice base. Being a low resource language, the work in the NLP involving Nepali language is already limited, and this work is also a motivation to the researchers working in the field of Nepali NLP. And going through the literature review, we have reviewed from the different different research paper, and among them we have gone through the a machine learning approach to automatic Bengali voice-based gender classification. In that, there the logistic regression method was used, and the random forest method was used, and it was published about in 2019. And next research paper we have reviewed is speaker identification using GMM.
Mr. Krishna Dev,
Yes, ma'am.
sorry to interrupt you in between, but your slides are not moving. On my screen, I'm only able to see the first one.
Yes, I too.
Okay,
Others
ma'am.
may please confirm the same, as the slides are not moving. Yes, now it's on methodology. Yeah.
On this methodology, we have collected data by ourselves, and we have gone through the different collection process. Like we have gone through the YouTube and individually collected from the different individuals by recording. And further, we have done our data Nepal data pre-processing and next feature extraction using. We have used MFCC for the feature extraction, and after that. We have trained our data in the Gaussian mixture model, and finally we got going through the result and discussion. Now we have altogether testing for the test data. We have 600 data. It is about 15%. And for the testing, we have altogether about 90%. And this is the configure matrix shown with the covariance type tied and the covariance type diagonal. In this paper, we detected the gender-based Nepali voice. And here we worked with nearly 500 speakers' voice and attended the voice using the GMM and detected the gender. We had used about 10,000 data samples in which we have trained 8,800 and found the training accuracy of covariance type tied is 91.65 and the covariance type diagonal is 95.4%. Similarly, the testing accuracy for the covariance tied is 93.8% and the covariance type diagonal is 94.16. We found the accuracy of the covariance type diagonal is more accurate than that of the covariance type tied. Out of 600 each tested male and the female voice, we found that in the type tied, the error ratio of a male and the female voice are nearly equal, whereas in the type diagonal error, the ratio is different as the female error is two more than the male error. This paper focuses only on the adult Nepali voice. In near future, we will extend it to the children and old aged people. And these are the reference that is a machine learning approach of automatic Bengali voice based. Thank you.
Hi, can you hear me?
Yes, sir.
Okay, so again, the same question. Why did you choose, you said you chose Gaussian mixture model, right? So why did
Yes,
you
sir. We
choose,
have used the Gaussian mixture model.
why did you use that particular model?
Sir, the data set in Nepali language is already, it is limited. We do not have sufficient data. So we have collected, we have gone through the data collection by ourselves. It is the best method for our Nepali data collection, and it has given the best result, sir.
Did you use any other classifier?
No, sir. Sir, in the literature review, we have gone through the different paper, and it has used different. Yes, we have tried, but it did not give us, sir, accurate result on the basis of our Nepali data that we have collected, sir.
Okay. You said you are going to add old and child voices, right, in future?
Yes, sir. In the near future, we will be extending it. This is kept as a base.
Okay, and can you tell me what are the features that you obtained for this classification? Then can you name those features?
So I did not get forwardly, sir.
Can you name the features that you used, or the features were auto-generated?
So features for? We have
Features
used, sir,
for class.
MFCC for the feature expression of our voice, sir, Nepali voice, sir.
I'm asking, did you use, what kind of features did you use? Were they auto-generated, or did you use some particular features to classify?
We classify it on the basis of the frequency of the speaker, sir. That data we have collected.
Okay, just on the frequency.
Yes, sir. Frequency based, sir. It is.
Okay. Thank you.
Thank you, sir.
Krishnadev, have you used any method to compare your this work, MFCC and GMM based, whatever you have done, that you
No,
have
sir.
compared with any other
It
method?
actually in that voice classification, there the other work have not been done. So in Nepali, we have used it. We haven't gone through the other, sir. We can do further research on the particular or the different types of feature extraction too.
Okay, so how you can say that this MFCC and GMM is best for this Nepali language or Nepali voice? Without
Sir,
any
actually,
without any comparison, how you can say?
Sir, in the Nepali voice-based gender classification, the other works it hasn't been done yet. So,
No,
so we have gone through the MFCC and
that
GMM.
is okay, but why you have chosen only MFCC and GMM? Because you have not gone through any literature review and you have not compared your work with other scheme. So how you can tell this MFCC and GMM is best for this purpose?
So we have gone through the different languages.
No, have you studied about the Nepali voice? Like Dr. Pallav sir asked to you, key features of Nepali voice.
Talking about the feature, no, sir, we have it. We have classified it on
Just
the
go
basis
to
of the frequency, sir.
sixth slide. Sixth number. Yes, here you are doing in third step feature extraction using MFCC features. So what are the features you are extracting here?
Mean frequency sequestral coefficients.
Okay, and
Frequency coefficient, sir.
and for data collection,
Yes, sir.
you have collected or you have used any pre-existing data set?
No, sir. We have collected it by ourselves, sir.
So
We have gone
what
through the individual, and we have used. We have collected from the web, and we have from the Google, and collected from the YouTube, sir. We have,
what precaution you have taken care during the recording of this Nepali voice?
sir, it was totally in the environment, noise-free environment, and from the YouTube, we have collected data, and we have silent streamed the data.
Okay, so you have collected from the different sources, not you have not
Yes, sir.
recorded.
We have recorded too, sir, but it was only up to a few, sir. It was only about 500 data we have got from the recording, and from YouTube too we have got the data about 6,000 data from the YouTube, and we have silent streamed it.
No, that data
So from the different sources we have got, sir.
which you have recorded. So have you prevented that background noise is there something? So
Yes, sir,
for
we have,
that
we have
purpose,
gone through
what
it.
you have done during recording purpose? So to remove the background noise and other things, what precautions you have taken care?
So we have silence streamed it. Using the library, sir.
Okay, okay, thank you from my side.
Christian Paul, am I audible to you?
Yes, sir. Yes, ma'am.
Okay. Right, as sir was asking you, my question is very simple. Like you have taken no other feature than frequency. How can you say that this classifier which you are using for the voice recognition is good enough? Because when we consider any signal, we cannot rely on any single parameter. So as you are not extracted the other features, can you tell me what are the features of the voice actually except frequency?
Pitch and the frequency. The male
Other?
spectrogram.
Any other you can name
Male
off?
spectrogram.
So when you are not considering that features, how can you say that this algorithm is giving you the correct or the accurate results? Is it okay that if we don't go for other features and if we only focus on any one of the feature, will it be, justifying the purpose?
Ma'am, I did not get it, sir. Ma'am.
Like you are taking only one feature into consideration and
Yes,
you have presented the result out of it. So my question is, will only extraction of one single feature will be enough to conclude the classification of voice? Will it
No,
be
ma'am.
good enough?
Yes, ma'am.
As you have not included the intensity, you have not included the amplitude, you have not included the pitch as you are saying. So
Yes.
will it be valid only to consider only a one feature out of many?
Yes.
Yes, how come?
No, ma'am, but we can go in the further in future.
Further, you have to incorporate because it is not enough. then the data you have collected from Google Web, and you are saying that you have also recorded some of the
Yes, ma'am.
audio signals, and YouTube also, from YouTube you have also collected the result. So are you finding any difference while evaluating the voices
Yes, ma'am.
during?
Basically, we in the recorded data we have got many noises, so we have resampled it and made it noise free, ma'am.
So are you taking the same features? Like what observations you have noticed while taking the data from the Google or from the web, or when you are taking the individual data? Are you taking this thing into consideration that all the assumptions and the noise factor is the same?
We have collected all the data. So suppose we have data we have collected from the YouTube, and we have collected from the recorded, and we have taken all the data and we have separated it into the male and the female voice, and then after we have converted into the we have a pre-processed it, and we have a silent system it by converting it to the web file, web audio, web needs, ma'am.
Are you sure that the data which you have collected from the various sources, they possess the same parameters?
Yes, ma'am. After silence streaming it, after resampling it, we can say that it is.
How you are doing resampling?
We have resampled it by using Librosa library.
I think maybe someone else is also there with you. I'm able to hear the two voices on a single platform. Right, Krishan, fine. Thank you so much.
Yes, thank you, ma'am.
Okay, I think we can go ahead with the next presentation, madam.
Yes, ma'am.
Okay,
Sure.
Thank you.
Now I would like to call Ms. Krishnapriya S to present his paper ID 272 titled as Surface Electromyographic Hand Gesture Signal Classification using a set of time domain features.
I hope the screen is visible. Hello.
Yes, ma'am.
Yes,
Screen is visible. You can
yes,
continue.
yes, please carry on.
Good afternoon. I'm here to present my paper on the topic Surface Electromyographic Hand Gesture Signal Classification using a set of time domain features. These are the contents I will be going through. Now, giving a brief introduction, hand gesture recognition has become quite common these days. It can be used to convey information between deaf and dumb people as a human-machine interface, of a robot control, and many more applications. So in order to acquire these hand gestures, you can either use data gloves, vision-based sensors, or SEMG sensors. Here we'll be focusing on the SEMG sensor. Now, SEMG, or surface electromyography, is a study of muscle activity based on the signals that are generated from the human muscles, which are collected from the surface of the skin by using some electrodes. The setup is as shown in this figure here. Now, if you can see, EMG signals have a wide range of applications. As you can see, some of them are like prosthetics, biometric systems, hand gesture recognition, and so on. But in order to apply them in these applications, the machine should be able to distinguish the signals corresponding to each gesture. So that is our task, to train a system so that it can classify the gestures based on just the signals. Now, briefly discussing the literature survey, different papers have, I've only included papers that are working on a specific database, a standard database, NINAPRO. And so the various papers have worked on different feature sets. So you can see from these papers, I've brought some conclusions, like some simple features like mean absolute value are enough to classify the gestures properly. And similarly, classifiers such as a random forest classifier is able to perform much better than other classifiers like SVM and KNN. And also it was noted that on combining some of the features, we are getting better accuracies when compared to when individual features are taken for classification. Similarly, some of the papers have given the importance of the number of channels. See, when more information is given, it will be easier to classify the gestures. And similarly, some of the papers I've used to understand the evaluation process. Okay. So now coming to the problem description. So from the literature, we can say that the performance of any gesture recognition system is mainly depending upon the classification accuracy and if a feature is able to distinguish the gestures properly or not. And from the literature, it was seen that on this particular data set NINAPRO, the maximum accuracy that was obtained was just 75%. So our objective is to propose a set of time domain features that will be able to recognize the hand gestures using the SEMG signal. And we'll be implementing the random forest classifier on this proposed SOTF. And also we'll compare its performance with other classifiers like KNN and SPM on this dataset, NINAPRO DB1 dataset. So coming to the methodology has three main parts: data acquisition, feature extraction, and classification. So in this initial part, I have just used the publicly available data set. So in the details of the database will be discussed in the coming slides. So the signal that is collected from each of the channels from the surface of the skin will be given to the feature extractor, and channel-wise features are extracted. The three features that I have considered are average, wavelength, and standard deviation. Since they're collected channel-wise, that is why there are 10 components for each of the features. Now these features are concatenated and we get a set of time domain features. And this set of time domain features are given to three different classifiers: KNN, SPM, and random forest, which will classify the gestures. Now going in deep to each of the blocks. First, the benchmark dataset used is the NINAPRO DB1 dataset. It has used the Autoboke, Bioboke, SEMG electrodes. And these sensors, there are 10 channels. The signals are being collected from 10 channels. 52 gestures are present in this database, collected from 27 subjects. And each subject repeated each of the gestures 10 times. Now, these are the gestures that are present in the database. And this database is divided into 3 exercises based on the type of movement present. Now, coming to the feature extraction, as I mentioned, the first feature that I've taken is average. It is the sum of the signal amplitudes in a particular interval. Then the next feature was wavelength. It is the sum of the absolute differences between two adjacent samples in a particular interval. And standard deviation, it is how much a signal amplitude varies from the mean value in a particular interval. Now these features, as I mentioned, were collected from each of the channels, and then the 3 of them were concatenated and given to classifiers. So from the literature, as I said, the random forest is our proposition. And so I've implemented the SOTF on random forest, and also to compare with other classifiers, I've also implemented the SPM with RBF kernel and KNN. Now coming to our results and discussions. So as you can see, there are 3 graphs corresponding to the 3 classifiers. First one for KNN, next SPM, and then random forest. In each of the graphs, I've compared the accuracies for the individual features, that is wavelength, standard deviation, and average, as well as the combination of the features. So in our proposition, which is the random forest, the SOTF is performing much better than the individual features. And also in each of the classifiers, I've also varied parameters like the K, which is the number of the neighbors, regularization parameter C for SVM, and the number of trees in the decision tree in order to find the optimum classifier for the SOTF feature. So after comparing, I've come to the best performance, which is, if you see the last line, which is for all the 52 gestures, KNN gives a performance of 82% accuracy, SVM 70, and RF is giving 86%. So RF is performing much better. And along with this, I've also included exercise-wise accuracies. And here you can see that exercise 3 is having an accuracy values which is much lower than 2 and 1. Now coming to the confusion matrices that I've obtained for the 3 separate exercises. Here you can see that the diagonal elements are having maximum values, which is expected for a good classification system. And there are some other values here and there which are showing misclassification. Okay. Now, if you observe the confusion matrix for the exercise 3, we can see that there is a lot of misclassification. There are many points which are not in the yellow scale. There are greenish and bluish shades, which is showing that those are misclassified a lot. And this could be the reason for a lower accuracy in exercise 3 when compared to 1 and 2. So we can say that our model is not able to properly classify the gestures in exercise 3. Now this is the entire confusion matrix for all the 52 gestures of the NINAPRO DB1 dataset. Now here I've compared the proposed work SOTF feature with RF with all other existing works which have been done on the same NINAPRO DB1 dataset. The only difference is they have used different feature sets and different classifiers. So we can see that our is giving an accuracy of 86%, which is much higher than those produced by other papers. And similarly, I've also compared exercise-wise accuracies. Like some of the papers have produced exercise-wise accuracies. Like the SOTF RF, our paper with exercise 1 is giving 87.65, where other papers are producing lower. And similarly for exercise 2, we are having 88.42, which is higher than another paper. Now, so I can conclude here that in this time is able to classify 52 hand gesture on the SOTF feature. We have tried varying different parameters to arrive at the best classifier for the proposed feature. We have reached accuracy of 86% by using SOTF and RF classifier on the NINAPRO DB1 dataset. And also we have compared the confusion metrics to come to conclusion that the gestures in exercise 3 are the ones which are mostly misclassified. So in order to overcome this, I am currently working on a 1D CNN model, which hopefully would improve the accuracy much further. These are the references. Thank you.
I have a question. Can I ask?
Yes, yes.
Actually, question I want to know that the data division is same in the existing paper as you done. The data testing and validation data that actually you have divided, the same is in the existing paper.
The ones compared.
Yeah, once compared. Yeah.
No, I have taken the majority. Like in most of the papers, they were 80-20. So I've taken 80-20. Not all papers are having 80-20.
Okay, so actually you are comparing your results with the existing data set. So data division should also same, like k-fold cross validation or training testing validation. How actually you divided data set. Okay. The same data in training, testing, and validation, then you can compare with the other existing works. Okay. Otherwise, definitely accuracy will vary. Okay. So. Okay.
Krishnapriya, same observation is mine also. You should compare all the method with at the same platform. Okay, so volume of data must be same. And one question, have you reproduced all the methods for comparison purpose, or you have taken only data?
No. There. Sorry, I did not understand.
You have reproduced for the comparison purpose that existing method?
No, the existing methods are from their literatures.
Okay, so that's why our suggestion is you have to either reproduce or you have to set the same platform for the comparison. Okay, then that will be good.
Okay, thank you.
Okay, thank you.
Krishnapriya, can you hear me?
Yes, ma'am.
Along with the suggestions which are already given by the other session chairs, I have only a single question that for the exercise that you are mentioning a less accuracy from the classifier which you have used, and you have also told the cause for the same. So can you suggest some kind of methodology to improve the same? So have you gone through from the literature?
Yes, I am not from the literature. The problem is those gestures in that particular exercise, they're very similar. For example, if I have a ball that I'm holding like this, another one which I'm holding like this, so they're very similar. So that is the problem that I'm facing. So I am currently working on a 1D CNN model.
Okay.
CNN is supposed to give a bit more accuracy, I believe. So I'm working on a 1D CNN. So hopefully that would increase. I'm not sure.
Okay, fine. Thank you from my side.
Hi, I have just one question. So the random forest is giving you the best accuracy, right?
Yes, yes.
Have you tried with gradient boosting?
No, I have not tried.
So I think generally this is the case that gradient boosting has a better accuracy than random forest. So you can, this is a suggestion, you can try that.
Oh, yes, sir, I'll surely try.
And also one simple question: why did you concatenate the data? Like
because I had actually I started with 10 different features. From the literature, I had a lot of options. I tried with separate features, then I tried different combinations. So this combination was giving me a better accuracy. So that is why I concatenated.
Okay, thank you.
Okay. Shall I answer?
Session chair, can we move to our next presentation?
Yeah, go ahead.
Thank you, sir. Now I would like to call Mr. Roshan Raj to present his paper ID 478 as discriminative feature construction using multi-labeling approach for automatic speech emotion recognition.
Good afternoon, everyone. Am I audible?
Yes.
Okay, sir. Fine. So, my name is Roshan Raj, and currently I'm pursuing MTech in CSE from NIT Patna. And I would like to thank MISP 2022 for organizing this conference and giving me opportunity to present my paper. So the title of my paper is Discriminative Feature Construction Using Multi-Leveling Approach for Automating Speech Emotion Recognition. So this will be the outline of my presentation. So a brief introductions and the dataset that I used and the techniques that have been previously used in the datasets, and also what are the different gaps that I found in the previous techniques, and the methodology that I have used to mitigate those gaps, and at last the result and the conclusions. So from a speech, when you identify from the speech signals, when you identify the emotions actually, so that technique is called speech emotion recognition system. So it is very useful in the application that demands like natural human computer interaction. And also, if you see that today's world, actually, we are all connected to different parts of the country, and people are using different languages. So using this speech emotion recognition system, actually, we can translate the speech with the emotions to the different languages. So the dataset that I have used for this paper actually is EmoCap dataset, which is very much popular dataset for this speech emotion recognition system, and it comprises of 5 recording sessions, like including males and females, and the duration of each individual session was like approximately 5 minutes. And in the dataset access, so they were used like 6 emotions, but mainly I have focused on the 4 emotions like angry, excited, sad, and neutral to compare the result with the existing work. And this is the plot of my data sets. So as you can see, like there are 6 emotions are there. Along with that, like each signals having different attributes. For example, arousal, valence, and dominance. So arousal means this attentiveness of the signals, and the valence means positivity, and the dominance means power. For example, if you take the example of this anger and excitations, actually, so both are having the same kind of arousal. That means the attentiveness is having the same, and the power is also the same. But if you see this, the valence attributes, that is like positivity or negativity, there's a difference in the angers and excitations. And the literature review is like they have used like different multitasking technique to categorize into like different representations. So in this technique, what they use actually, so along with the primary task, they are also using this auxiliary attributes to identify the classifications. For example, like the main task classifier can be better trained with the secondary related task. For example, like facial verification and the facial landmark prediction is used as auxiliary task. That means like secondary task for the facial emotion recognition. So the same way, I have used different attributes like discrete emotion classifications, arousal, valence, and dominance attributes as like secondary task to identify the actual emotions of the signals. And this is my problem description. So I want to try this multi-level approach. Like first we extract the features using this other attributes, and then we want to classify the actual emotion classes. So that I want to try using this multi-level approach. And in this paper, my main contribution is like using this interesting correlation among different emotion with arousal, valence, and the dominance attributes using multi-level approach to enhance the performance of a speech emotion recognition system. And for extracting this descriptive features, these are the steps that I have used. So first, I have taken this speech signals, and then I have transformed this speech signal into a spectrogram-based representation, which is like time frequency representation of the signals. And then I have used it's a simple CNN-based architecture to extract the features using the secondary attributes of the signals. So into 13 different, whether the output of this output of this architecture was like 13 different class problems. And then after extracting the feature from these models, I have fed this extracted feature into different models to classify the four emotion classes like angry, sad, or neutral. And this is the frameworks that compose CNN blocks and this output layers. And if you see deeply in the CNN, I've used a typical CNN blocks where the exponential linear unit there at least, and then the output layer is there. And in the output layer, like we have used this one hot encoding vector. So it can visualize as here actually. So I have used as like input size of the spectrogram, so which is size of like 201 cross 600, and I have used like multiple CNN blocks. And this is my like global average pooling layer is my like feature extracted. From this layer we have extracted the feature from the next models, and here I have used like 12 different classes. So in the data set actually, so they have given like arousal feature is having like continuous values like 1 to 5. But in this case, I have used one encoding and also have categorized this into discrete values like 0 to 2 as low, and then 2 to 3.5 as mid, and then 3.5 to 5 as high. So from this we have used like arousal having 3 categories, and then valence is having 3 categories, and then the dominance is having 3 categories. And this I have used this one hot encoding, and at the time actually from each segment one of the vector will be present actually. So at any point of time, like 4 of them will be present, 4 of them will 1, and all of them are 0. And once I have extracted the features from this layer, the global average pooling layers, like I have trained this model completely from end to end using all the other like arousal, valence, and dominance attributes. And then I have passed my test and training data, and then I have extracted information from this layer. And then I fed this information into different models using like 2 deniance layers, and then the 4 output class, angry, excited, neutrals, and sad. And so here I have just tried to do the comparison of like single level versus the multi-level features. So these are the these dots represent the different classes. So in the left hand side actually these represent like how the features are distributed across this thing. So here you can see like we wanted to have like more of a like similar feature. We wanted to have more group together. So if you see the comparison, the second figure gives like more of a grouping. Here we can see the more of grouping, which is like multi-level approach. So that gives the better performance compared with the single level approach. And this is a matrix that I've used to compare with a single level model and the multi-level model. And here WA represent weighted accuracy and UWA represent unweighted accuracy. So UW is like UW is like very much is much more comparable if the database is like more imbalanced. So here we wanted to focus more on this unweighted accuracy. So if you see this comparison with the accuracy of this unweighted accuracy, the multi-level model is giving much better accuracy compared to the single level model. And this is a confusion matrix of the multi-level model. So where we have like in the one side we are having like 4 classes, and then along with that like how many are getting correctly identified, this diagonal thing is giving, and the other is giving like what are the misclassifications happening. And this is the this is where I have compared with the other techniques that I've used in the previous papers. So where they have used like different features and different models in the different for the same database. So here if you see, this is my proposed model actually. So where I have achieved this unweighted accuracy at 62%. But in terms of weighted, actually, I was not focusing on weighted, but still it is giving like comparable with the other papers. And at the end, the conclusion, actually, I would say, like, I have used this multi-level framework approach to generate this first multi-level framework approach to first generate the descriptive features. And based on this arousal, valence, and dominance information that was present with the speech signals. And then I've used the CNN architecture to extract those features. And then after extracting the features, we have used like single level framework. We have used this extracted features into different dense DNN models to classify the signals. And this in terms of multi-level framework, actually it is giving a better unweighted accuracy compared to the others. And in further for the future work, actually one can say that actually they can also, along with this other along with this dominance or the arousal valence attributes, actually they can also use gender and speaker information to as I say, auxiliary task to classify the signals. And these are the references, few of the references that I've quoted here. And that's all from my side. And thank you for listening. So questions are welcome.
Roshan Raj,
Yes, sir.
have you reproduced all the methods?
Sorry, sir. Actually, I've just taken, because I've used the same data set, so I've just quoted the result actually. So I've not used those features actually. So.
Okay, so same data set and same platform, same, everything was same.
Yes, sir. Actually, so data set was same. Actually, the platform, the system they have used like maybe different actually, but the data set, the ratio was same, sir. Actually.
No, yes, sir. Actually, the division of data set is also same, sir. That paper actually we have considered.
Okay.
Yes, sir.
And since you are using multi features, so all obviously complexity will become more in your
Yes, sir.
method. So to reduce complexity, have you done anything, or you are thinking about that?
So still I have not like figured out like these things actually. Definitely there's a more complexity, but yes, sir. Actually, I will think later, sir. I mean, in future, actually, I will try to.
Actually,
thank you for
sir,
the sessions, yes, sir.
Actually, sir, when we go to deep learning, then definitely complexity occurs. But when we train model, so after training models, the complexity is less. We have only the trained model. So we have to actually compromise with if we are going to deep learning, then we have to compromise with the complexity if we are eagerness to accuracy. Like uncertainty principles are like both cannot achieve simultaneously.
Yes, both cannot achieve, but we have to optimize.
Yes, sir. Yes, sir. Yes, sir. Definitely.
Okay, thank you.
Thank you, sir.
Roshan Raj, all right from my side, as all the queries are already being raised by Dr. Sandeep. Thank you so much from my side.
I'm good.
Yeah, thank you so much.
Thank you, sir.
Any more queries, session chair?
Shall I stop sharing my screens, ma'am?
No question from my side.
Same here. It's all right from my side as well. Yes, you can stop sharing it if.
Okay. Okay.
Right.
Thank you, ma'am. Thank you, sir. On behalf of NIT Raipur and organizing committee of the conference, I thank you all. I thank you all for sparing valuable time as well as providing valuable insight to the authors. It is kindly requested to fill the evaluation sheet so that the past paper award can be decided and finalized. Thank you, sir.
Excuse me, actually that evaluation sheet we are not able to access.
Okay,
Yes, that's true.
sir, I will mail you again. Within 5 minutes, I will mail. I will be mailing you, sir.
Okay. Okay.
Okay.
Thank you, sir.
Thank you.